All right, hey everybody. This is video 331. It is the third unit. We are on our final standard, our third standard for the unit, which is that we want to graph and identify key characteristics of absolute value. So that's what we're going to be working on, graphing and identifying key characteristics of our absolute value functions. So go ahead and write this down at the top of your paper, your notes. Make sure you're in the right spot, and you don't necessarily need your graphing calculators. We'll do a little bit more of that in class. So just have your paper and pencil, and we'll get started. All right, we're going to begin with just a little bit of vocabulary, and this right here is our absolute value function. Okay, it is a transformed function, meaning that it is not the parent function. So a parent function would just be a plain old f of x equals the absolute value of x. A very simple, nothing to it. I would just put in numbers and I would keep getting outcomes. Here, we got all sorts of other things going on, and we're going to talk about what each of these things are. So this again is called the parent function. And what we have here is the transformed function. By transformed, I mean we changed it. We transformed it. So we're going to talk about the A. The A is our multiplier. And our multiplier is either going to stretch or compress the graph. It's either going to stretch or compress the graph. And a stretch is going to be when A, and this is going to be interesting because we're going to talk a little bit more about and clarify this, when A is greater than 1. Okay, and then compress when A is less than 1. Now I'm going to put some qualifications. I don't actually want it to be negative. We're going to consider that. I don't want A to be negative. So how do I fix that? I want it to be between 0 and 1. So what am I talking about? I'm talking about fractions that are less than 1. Okay, so I'm talking 1/2, 1/3, 2/3, 3/4. As soon as I talk about, if I just use the word fraction, we might get confused because, by the way, 5/2 is a fraction, but it's not between 0 and 1. So that would actually qualify as a stretch. Well, then you say, well, what about when we have A's that are like -7? Well, we're going to talk about that negative, and it's going to mean something else. H is the horizontal shift. It's a horizontal shift, meaning it moves left or right. And K is our vertical shift. And so this takes our function, it moves it up and down. That's our vertical shift. So our vertex actually comes from the H and the K. Now I want to point out something very important. There is a negative sign built into this equation. The negative sign is built in. So when we look at these later on with our examples, it's not that I'm taking the opposite of H, it's just that the negative sign is built in there to begin with. The K is a plus a number, so that one, I'm just taking the number right out of it. Now, my rate of change. My rate of change is going to be plus or minus the A. And as we remember from the last standard, where when we get that rate of change from our table, we saw that they were opposites. One was positive and one was negative. All right, get that down so that we can reference it as we try a few examples together. So pause if you need to and then move on when you're ready. So here's our first example, and we're going to be graphing it by hand. So we're not going to be using our calculator and we're not going to be using Desmos. So the first thing we want to list are what are the transformations that happen to this? And I can see that there's a 2. This 2 in here is a positive 2. I know it says minus, but that minus is because the negative is built in. So the 2 in there means that this went to the right 2. That 6 over here means that this went up 6. So let's consider what that means. If I take this graph and I move it to the right 2 and I go up 6, right there, that's what we call the vertex. So 2, 6 is my vertex. It'll make a little bit more sense when we start graphing them, but you should remember this from our Desmos activity. Now the rate of change. The rate of change is that plus or minus the a value, but in this case my a value is 1. So my a equals 1. So there we go. My rate of change is 1, which means that there was no stretch and there was no compression because I don't have something other than a 1. And now we're going to make a table. When we make a table, we want to put our vertex in the middle, and this is going to give us that symmetry. So I will have 2, 6 in the middle, and then I will pick points for x that are on either side of this of the 2. So for example, if I want to go smaller, I would go 1 and then 0, and then a bigger, I would go 3 and 4. Because of my rate of change being 1, I'm going to see that on both sides I will have symmetry, but let's substitute in the 1. Let's substitute in the positive 1. That means the absolute value of 1 minus 2 plus 6. This is 1 plus 6. Remember, because it's the absolute value, so it's 1 plus 6, that makes a 7. Well, if that's a 7, then this is a 7. Let's try the 0. The absolute value of 0 minus 2 plus 6, that makes the absolute value of 2 plus 6 is 8, which makes this an 8. So now I'm ready to plot those points, and I can see that my rate of change is positive and negative 1, meaning that on both sides it's going to have a rate of change of 1. And this, with arrows, is my absolute value graph. Let's try another example. All right, starting by listing our transformations, I can see here that I have a plus 1, which means that it was x minus a negative 1, which tells us that this went to the left 1. It didn't go left negative 1. The negative tells us that it went to the left. And this tells us that it went down 2. Now we have this 2 in front, which is a stretch of 2. Our vertex still comes from the left and down. So we went left 1 and down 2, and that is going to be our vertex, negative 1, negative 2. My rate of change is plus or minus 2. Again, that's from the a value. Let's go ahead and make a quick table. We're going to put the vertex in the center of the table, and we're going to choose x values on either side. If I want to go smaller, I go negative 2, negative 3. If I want to go larger, I go 0 and positive 1. Now let's go ahead and apply this rate of change rather than substitute the values in to make the table. So if I'm counting by 2's, that means my next value here would be at 0 and 0. And then I would have positive 2 and positive 2. So there is my rate of change being applied. And let's go ahead and graph that. So once again, I can actually just graph by going up 2 and over 1 in both directions. And that's the 0, 0 point that we had right there and the negative 2, 0 that we've got there. And then up 2 more and over 1 and up 2 more and over 1. So you can see that this one was more narrow than the last one. Let's try another. If at any point you need to pause and make sure you understand it, please do. Don't rush through this. It's going to be more important that you take your time and you take all of the notes. All right, let's take a look at our transformations. Here I see minus, but the 3 is what we really want to pay attention to, because remember that this is negative sign is actually built in. So this went to the right 3. Because there's nothing written on the outside, it did not go up or down. I could write that it went up 0, but that's unnecessary. It just didn't move up or down. And then here, this is a compression of 1/3. My vertex, well, if I only went to the right 3 and I didn't go up or down, then that makes my vertex 3, 0. My rate of change. My rate of change is plus or minus 1/3. And then let's go ahead and make the table, again putting the 3, 0 in the middle. But this time, in order to use that 1/3 wisely, I might want to think of which numbers I want to put in my table. And to go smaller, I might go down to 0 and then negative 3. And to go larger, I might go 6 and 9. And that's just going to make my points a little bit easier to work with if I'm multiplying by 1/3. Another thing to consider is why not go ahead and just go up 1 and over 3 to the right. So up 1, 1, 2, 3. The other way, up 1, 1, 2, 3. And do that twice. Up 1, over 3, up 1, over 3. If you're not certain that that's going to give you the correct graph, oops, did I not go over enough here? Nope, that looks good. If you're not certain about this being the correct graph, you can always verify your points. At 0, if you put a 0 in, 1/3 times the absolute value of 0 minus 3 is 1/3 times the absolute value of negative 3. That's a 1, and that's exactly where that point is right there. So the table isn't necessary, it's just used to help you. All right, I think we've got one more here. Okay, so we got a couple different things going on. There was no left or right change that happened in here, so we don't have to write it down. However, it did go up by 5. And then lastly, we've got right here, we've got this -2. Now we're going to talk about this separately. That negative sign is actually a flip. It's called a reflection. Okay, then we also have a stretch by 2. So we had two things that went on with that -2. The negative is the flip. It flips it upside down. And the stretch by 2. My vertex, since it did not go left or right and it only went up 5, is 0, 5. My rate of change is still plus or minus 2. Don't worry about the negative sign. The only thing the negative sign tells us is that it goes upside down. And for this one, for the table, my XY table, I can put the 0, 5 in the middle. But this time, instead of my first step going up, it's like I'm subtracting 2 from each one, and then 3 and 1 for each of those points. So maybe -1 and -2, and +1 and +2. Well, let's just graph it using our rate of change. Down 2 and over 1 in both directions. Down 2 and over 1. Down 2 and over 1. And there it is. You've got another graph. Please go back and review any of this that we mentioned, especially the transformations and the vertex, and then how we can get that on the graph. All right, then go ahead and try the entrance slip, and we'll keep working on this in class together.